All right, so in this problem, we have train A runs back and forth on an east-west direction, on an east-west section, excuse me, of railroad track. Train A's velocity measured in meters per minute is given by the differentiable function v of A, or v sub A of t, where t is measured in minutes. Selected values for v of t sub A are given in the table above. At time t equals 2, train's A position is 300 meters east of the origin station. Interesting name. And the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. Okay, cool. So what do we do? Well, I'm going to show you. That's my job, sort of. So the idea here is to basically calculate a sum of trapezoids, which will then be used to tell us how far the train was displaced from time 0 to 12. But we have also taken into consideration that it was 300 meters east as a start. So let's first recognize what's going on. Like, let's first recognizing that we haven't recognized. Let's first make sure we understand, the difference in position, velocity, and how they're related. So we want to figure out the position. So we want to figure out S of 12. Find S of 12. That's our goal. Now, S of 12 will be the starting position, because it tells us at S of 2. S of 2 plus, so it was 300 meters east of the origin station at 2 seconds, or 2 minutes, plus however far it was displaced over that time period. So we can find this by simply taking the integral of v of t sub A from 2 to 12. You only go from 2 to 12 because we already have the position at time equals 2, dt. Now, we should, or hopefully by now, or have learned that if you integrate the velocity function, that will give you the change in position or the displacement of an object. Because again, the antiderivative of velocity is position. The derivative of position is velocity. So again, when you integrate the velocity function from some time to another time, it'll tell you how much the object was displaced from that time, over that time period. So this will tell us how much the train was displaced from time t equals 2 to 12. Now, again, we don't have the equation for the function, so we're going to use a trapezoidal sum approximation to get an idea of what this would equal. So this will be 300 plus these 4 trapezoids. Now, let me I'm gonna draw a picture of this. That's it's fun. I like drawing pictures, and you should too. But it also lets you understand really much easier what's going on here. So let's draw a graph. Sketch T and V. So 0, 0. With a care 2, 0. 2, 5, 8, 12. It's all the way down there, but just actually I'm gonna move it up a little bit. At 2, the velocity is 100. So we'll call this 100. So 2, 100. 5, the velocity is 40. So 5, 40. 8, the velocity is negative 120. So 8, negative 120. And at 12, the velocity is negative 150. So the idea here is basically to calculate the sum of these four trapezoids if you would make them from across these intervals. Now, one of these trapezoids is going to be kind of strange looking. It's going to be positive to negative. Or actually, the last one, something like that. Yeah, so now this is going to seem a little weird or abstract because you have negative trapezoids or areas below the t-axis, but the principle is still the same. Um, these will be positive quantities, they'll be negative quantities. So we just basically find the average, across each interval. So this would be equal to, this part would be equal to this width 3 times the f of 2 or v of 2 or 100 plus 40. So v of 2 plus v of 5 or 100 plus 40 divided by 2. So the average of those. Plus the next width would be from 5 to 8 is 3. Plus 3 times the averages. This case would be 40. This one would be negative 120. 40 plus negative 120 divided by 2 plus from 8 to 12, 4 times negative 120 plus negative 150. Over 2. So again, we're using the base, we're getting an approximation for this, these, trapezoids, triangles, so to speak. And we get that that'll be 1.5 times 140 plus 1.5. Oops. Times negative 80 plus 2 times a negative 270. And we get, let's see what we get now. So you get negative 450. Okay, so what does this mean? Well, it's basically saying that from time t equals 2 to 12, the train changes position by 450. In this case, is a meter? No. Mm, 50 meter, yeah, I'm sorry, meters. I'll took you off. So from time t equals from time 2 to 12 minutes, the train changes position by 450 meters in a negative direction or to the west. So remember our compass, our directions: north, east, west, south. But we have to make sure again we count this 300. It was 300. It was its position initially was 300 meters east. So 300 plus a negative 450, and we'll get negative 150 as its final position when t equals 12 minutes. So overall, the train ended up being 150 meters to the west of origin station when we're done here. So let's go ahead and write that time. The train is approximately meters west of origin station.